Assalamualaikum. My name is Muhammad Azhar Akmal. Today, me and my friend we will explain and present about the basic chromatography. Chromatography. We will explain about the understanding the principle and real world application for the basic chromatography. So this is our table of content. We have 8 things we highlight. So I will explain three of the 8. So the introduction, the purpose, and the last one is the type of chromatography. So first we go to the introduction. What is a chromatography? Chromatography is a method used to separate mixture by passing them through a sanitary paste, while a mobile paste moves through it. The different components of the mixture travel at varying speeds, allowing their separation based on their affinities to each paste. So the second one is a purpose. The purpose of chromatography is to separate and analyze complex mixture, enabling to identification, purification, and qualification of individual components. It's a very widely applied in fields like chemistry, biology, environment science, and forensic to ensure quality, safety, and accuracy in various applies. So now we go to the type of chromatography. So we have a four type of the chromatography. The first one is a paper chromatography. It's a simple method where a mixture is applied to the strip of paper. The mobile paste is solvent and moved through the paper, separating components based on their solubility and affinity to the paper. The second one is a thin layer chromatography, or we call it TLC. It is similar like a paper chromatography, but use the thinner layer of silica or alumina on a glass of plastic plate as a sanitary paste. It's a more precise and sensitive than paper chromatography. The third one is a gas chromatography, or GC. The tanning where the mobile paste is a gas and the sanitary paste is a liquid or solid inside the column. It is used for the separating volatile compounds, commonly in environment and forensic application. So the for the last one is a liquid chromatography. It's what we call LC. Involve a liquid mobile paste passing through a column filled with a solid sanitary paste. It used for a wide range and substance, including the tools of the pharmaceuticals and biochemical analysis.
So for the next slide, we're gonna look at stationary phase. The stationary phase is the non-moving part of the chromatography system that retains the components of a mixture based on their interaction. It provides a surface or medium over which the mobile phase flows, facilitating the separation of substances. Next slide, we're gonna look at type of stationary phases. The first one is solid stationary phase. It used in thin layer chromatography, TLC, and column chromatography. Its common materials is silica gel and alumina. The components interact with the surface, separating based on absorption. Second one is liquid stationary phase. It causes a solid support in techniques like gas chromatography, GC. The separation occurs based on the solubility of the component in the liquid phase. Lastly is paper stationary phase. It used in paper chromatography. The paper acts as a medium with water or another liquid absorbed into it, allowing separation based on solubility and capillary action.
The other phase that we got is mobile phase. The definition of mobile phase is the fluid that carries the mixture of substances through the stationary phase. It can be a liquid or a gas. This phase functioning as the primary role to transport the components of the mixture through the stationary phase. And then we got the types of mobile phases. There are two of them. The first one is liquid mobile phase. It is used in liquid chromatography. It can be water, organic solvents, or a mixture of both. The choice depends on the nature of the sample and the stationary phase. The second one is gas mobile phase. It is used in gas chromatography. It is common gas include helium, nitrogen, and hydrogen. The gas must be inert to prevent reactions with the sample or stationary phase.
To go to how chromatography works, we'll go to the process flow. So the first one is sample application. Mixture applied to the stationary phase. The second one is development. A mobile phase moves through the stationary phase, and the last one is detection, which the components separate and are detected. And the next one, real world application of this chromatography. So chromatography actually uses in the forensic science, where it can identify drugs, toxins, and other substances. Also, it can use in food industry by ensuring quality and safety by identifying additive and contaminants. Also, it can use in environmental monitoring, detecting pollutants in water, air, and soil. And lastly, it can use in pharmaceuticals, in purity testing, and also compound isolation.
So now let's go to the example demonstration. The first step is the chromatography paper is cut about 2.5 multiplied 10 centimeter strip along one of the shorter sides. Draw a horizontal line in the pencil. Lead will not move about 1.5 centimeter from the edge of the strip. This will be your baseline, the starting line where the sample will be spotted. Then step number two is apply a dot of ink from each black felt-tip pen of the baseline. Make sure dots are evenly spaced on the baseline and not too close to the edge. It may be helpful to use pencil to mark the spot before placing the ink of the paper. See diagram below. Step number three is label each spot in pencil so that you know what each spot is. The last step is stamp the paper in the eluting solution, tapping the top of the strip to the side of the beaker may be helpful. Now we go to the advantages and limitation. For the advantages, chromatography is highly sensitive, capable of detecting and separating even the smallest quantities of substance. This sensitivity makes it ideal for analyzing complex mixtures where precision is crucial. And then we go to the limitation. The cost of advanced equipment such as gas chromatography or GC or high performance liquid chromatography HPLC can be prohibitive, especially for smaller labs. The process can also be time consuming with some methods requiring latent preparation and separation time. And then we go to the summarize. We can summarize that chromatography is a key analytical technique for separating and identifying mixture components. It offers high sensitivity and versatility but can be costly and time consuming. Widely used in various fields, it provides precise analysis, making it essential in scientific research and industry. So that's all from us. Thank you for watching.